Okay, today we are going to start a lab on switching circuits. In this lab here, we're going to basically understand the functionality of switches, how they function, how connections are made. We are going to use same information that you have in your module for switching circuits, and we're just going to represent it here in our lab today. We're going to use our ohm meter that I have right over here. I've already set it up for you, and I have the multimeter set up as an ohm meter. I have an extra set of leads here which are connected to my meter, so I can see what you're seeing on your end there. We're going to use an ohm meter to indicate function of various types of switches that we have over here, and see when a connection is made and when a connection is broken. So we will understand functionality of a switch. The first one that we're going to look at is going to be, I'm going to refer to it as a 401 switch, and we're going to see how the switch makes a connection, how it functions, and how it operates. Using an ohm meter, we can indicate on the ohm meter on the reading over here, if we see a reading that reads OL, that refers to over limit, and that indicates a very high resistance. As far as our switches are concerned, that means that there is no connection. When a connection is made with our switch, that would indicate that we have either a very low resistive value or no resistive value. Typically with the switches that we have here, you will see that there will be a very low resistance value, typically between 0 and 1 ohms. Okay, so let's just get started on the first one here. You'll notice that I have two red leads together and two black ones. These just allow me to see my meter to indicate what you're seeing. So now knowing how this switch works, let's just connect on this green one and the white one. You see that on your meter there, we still see the symbol OL. I'm just going to flick the switch here. Nothing happened. Flick it back. Still nothing happened. So there is no connection whatsoever between this green terminal and the white terminal. Let's try between the two yellow ones. Okay, so I've got my meter connected. Right now I have meter still shows OL, no resistance, so there is no connection between the two yellow points. When I flip my switch, my meter changes. Now you have a reading of 0.1 ohms. This now indicates that there is a connection between the two yellow points, two yellow terminals right here. So when the switch is in this position, there is a connection between these two yellow points. And when I flip the switch back to the other position, now it goes back to OL. So basically this connection here now is broken. There is no connection in between there. This will be an indication of a single pole switch. So what I'd like to do is to represent, I'd like for you to draw on a piece of paper, schematic drawing, same symbol that you would see in your modules, either on page 5, 6, or 7. We have schematic symbols for each one of the switches. This is a single pole switch, and you can indicate when there is no connection. We can indicate that with a dotted line, and when there is a connection like this, now we are measuring resistance between these two terminals. That indicates that there is a connection. We can indicate this by a solid line. So when the switch is in the up position, we have a solid line, and when it is in the other position, we have an open or a dotted line. Okay, so we also indicate switches whether they are open or closed. This is in the open position. We have infinite resistance, OL, and then when we put the switch in this position, the switch is now closed. There is a connection between these 2 points. Okay, very good. let's go to the next switch. Okay, let's work on a 402 switch, and we're only going to be concentrating on typically the yellow terminals, not the green one or the white one. So we're going to figure out, based on these 3 yellow terminals, where connections are made and where there is no connection. So let's just start with these 2 terminals here, the 2 yellow ones on this side, and I'll put one black lead over here and put a red lead over on here, and we still see that there is no connection. So this is still an open switch. I'm going to change position of the switch to the other position. We still have an open. So in either switch position here, there is no connection between these 2 terminals. So there is always an open between these 2, never a connection. All right, well, let's take the red lead and change it to this yellow terminal over here. And as soon as I put it there, you see that we have a resistance of 0.1 ohms. So now we actually do have a connection between these 2 points here with the switch in this position. If I change the switch position, let's see if that changes connection between these 2. Right now it's closed. Now we go to OL, so now this connection here is open. Okay, there's no connection. This way it is closed. We have a resistance value, 0.1. Here we have no resistance, that is open. Let's take our black lead to this other terminal to see what's happening between this yellow and this yellow. As soon as I plug it in, I see that I do have a resistance value. So actually I'm measuring a value of resistance between these 2 points here. So I actually have a closed connection here between these 2, and when I flip the switch to the other position, now there is no connection. So now that's an open. So we can see here that we have a switch connection that makes and breaks a connection. Either we are open like we are now, and then if we flip the switch, now we have a closed connection. While I have a closed connection here, let's see what's happening between this red and the yellow terminal. So right now this is a closed connection, and this, we have OL, we have infinite, this is an open connection. Once we flip the switch to the other position, now we have a connection or a closed switch here, and between the other 2 terminals we have an open connection. So this is a representation of what we call a 3-way switch. Typically, I'm just going to pull my leads out for a second here, just to indicate that this here is your common connection, and it will either switch between these 2 points and make a connection while these 2 are open and these 2 are open. Then when we flip the switch, it will make a connection from the common down to here. Now we have a closed switch here. Between these 2 terminals are open, and between these 2 terminals they are always open. So that's the functionality of a 3-way switch. This would be our common, and every time we flip our switch, it changes connection either from these 2 yellow terminals to these 2 yellow terminals. One will always be a closed side and the other is always open. But here, this is closed, these 2 are open. That would be a 3-way switch. So typically you can draw a schematic of this showing a solid line, for example, between here and here, and this would be your dotted line. When we flip our switch, this becomes our solid line, this becomes our dotted line. This is a representation of a 3-way switch, and you should be able to write that down to indicate that that's a 3-way switch. All right, let's go on to the next one here. This one here is represented by the numbers 403, and we'll see what this one here does. Now I'm just going to start with my leads on these two yellows. We have 4 yellow terminals, so we're going to find out what each one of these 4 terminals, how they are connected. And actually, I'm just going to turn my switch around so you guys can see that. So in this switch position here, the switch position is in the down position. The meter indicates OL, or over limit. There is no connection here. Let's see what happens when we flip our switch. We flip the switch to the other position. There is absolutely no connection there, either switch position. So that is always an open. Okay. Let's try between these 2 terminals here. Right away, I have still OL indicating open circuit. So this is an open, there's no connection. We flip the switch to the other position, it is still open. So what we have here is in either switch position, there is no connection between these 2 and between these 2. So we never have connection here or here, either switch position. All right, let's try putting our leads over on the one side, the left side. And right now our meter still reads OL. Well, we still have it open between these 2. Let's see what happens when we change switch position. Well, now we're measuring a resistance finally. So now when the switch is